Hi friends, welcome back to Fundamental Concepts at Ease. This video presents some of the important problems on the concepts already discussed in previous video on vectors and scalars. In this video we learn about how to solve the problems relating to vector addition, resolution of vectors, cross product and dot product. So if you have any doubts with regard to this problem solving, you can comment on the comment section, and please do subscribe such that you will be updating regarding the videos presented to you. So we'll jump to the first problem of the section. The first problem is about two forces acting on a body, 10 newtons and 15 newtons, and what can be the maximum and minimum resultant forces on the body. So when you are doing any problem, first of all we have to understand what is given in the problem. So here they are giving two forces. We can call them as A vector, that is equal to 15 newtons, and one more is B force, that is 10 newtons. Okay, so what we have known is we have to find the resultant of this one. What is this? Fine. He is asking to find what is the maximum resultant and what will be the minimum resultant. So what we inferred from the previous topics is, according to parallelogram law of vector addition, right? So what it tells you, there is a one vector A is acting like this, or one more vector acting B. There is an angle between them, right? So we know as per parallelogram law, this is the resultant, right? Sorry, this is the resultant. So we have to find what is maximum and what is minimum of this one. So according to parallelogram law, we know that resultant is equal to A square plus B square and 2A P cos theta, where cos theta is the angle between these two vectors. So in this equation, to find what is the maximum Rx, if we are saying our maximum is Rx, and R minimum is equal to Rmn. We will term this way. So in order to have a finding the R maximum, the only issue is here cos theta. So when cos theta having values of like 0 to plus 1, we know. So this happens when theta is equal to 90 degrees to theta is equal to 0 degrees. So in this way we know that when theta is equal to 90 degrees, we have cos theta is equal to 0. When theta is equal to 0 degrees, we have theta is equal to 1. That means when it is 90 degrees, that means the angle between these two is 90 degrees, this whole term becomes 0. Like see 2A P cos theta is 90 degrees here, that is 0. So this whole term will be 0 into anything is 0. So we are only left with A square plus B square. So that will not be a maximum value for what you are finding. So this, because this value will be vanished when you are using 90 degrees. So if you are using in between, suppose we use cos theta is equal to some 45 degrees, or some suppose you assume that cos theta is equal to 60 degrees. So cos 60 will be how much? Sorry, this is cos 60. Sorry, equal around point. I am assuming it is 0.5. Not very sure. So when it is 0.5, this will be how much? A square plus b square plus 2ab cos theta cos 60, that is equal to 1 by 2. To 1 by 2. So this will go, this becomes only ab. So here we can write it down as b square plus ab. Still we don't know whether this is a maximum value or minimum value. Okay. Suppose if it is 1, if cos theta is equal to 1, then this will become a square plus b square plus 2ab. So definitely this is a1ab and this is 2ab. So this is, when you are adding these three, this will have a maximum value, right? Okay, let's write this. So here we see that when cos theta is having from 0 to value of 0 to 0.1, 0.2, 0.3 up to 0.9 and 1, then r square here, a square plus b square plus 2ab cos theta. So when you substitute these values in here, in this, suppose in this, the value of r will be equal to r square plus 2ab into different values of one time 0, next time 2ab into 0.1, next you see 2ab into 0.2, like that 2ab 0.9 plus 2ab to 1. These all this, so these are all common. Okay, these all these things, the final value you see, this is a square plus b square plus 2ab is having the r maximum value, right? Because this will be less compared to this one. All this, suppose this is r1, this is r2 square. Yes, I'm just saying for different values of cos theta, I'm just taking the value like. So final value, when r is equal to 1, this cos theta is equal to 1, this will be having largest value. So r1 will be greater than these, all these things. So that will be the maximum value. So this is happening when theta is equal to 0 degrees, right? So here we will write r maximum is equal to a square plus b square plus 2ab into cos theta is 1, 1 here, 0, because theta is 0 degrees. So again this is equal to a plus b whole square, right? So in the problem is given that vector a is equal to 15 and vector b is 10. So that will be equal to 15 plus 10 whole square. It is 625. So r square is equal to 625. That is equal to root of 625. That is equal to 25. So r maximum is 25 newtons, right? So now we found out what is r maximum. So again we have to find what is r minimum, right? How we will find? See, in this equation, suppose the cos theta is taking negative values, that means minus 0.1, minus 0.2, minus 0.3, minus 0.19, minus 1. That means when cos theta equal to 0 to minus 0.1, minus 0.2 to minus 1. So similarly what happens here? This is 0, 0 doesn't change anything, this becomes 0. Here this is minus, suppose take, it becomes minus here, there is no more plus. So this becomes minus, so this becomes minus, and this is minus 1, right? So that's why what I'm saying is, so r square will be equal to a square plus b square plus 2ab into cos theta if we take minus 0.1. This becomes minus 2.2ab, right? 2a square plus b square. Similarly, if you take cos theta is equal to minus 1, what happens? Okay, plus b square is equal to plus 2ab into minus 1. So this is equal to minus 2ab. It is a square plus b square minus 2b is equal to r square. So this will have, because this is the maximum value which has been removed from this two terms. Similarly, in r maximum case, for this value, for this term we are adding 2ab, but in the case of r minimum we are subtracting this case, that is a square plus b square minus 2ab. So this happens only when cos theta is equal to minus 1. So this happens when theta is equal to 180 degrees. So this turns out to be like when theta is equal to 180 degrees, cos theta turns out to be minus 1. That means in this term a square plus b square plus 2ab minus 1, that is 2ab minus, this is equal to a minus b whole square. So r is equal to a minus b. As you know that our vector a is equal to 15 newtons and vector b is equal to 10 newtons. So we substitute this values here, that is 15 minus 10, it is 5 newtons. So we got r maximum is equal to a plus b and r minimum is equal to a minus b, that is equal to 25 newtons and this is 5 newtons. So we had geometrically r maximum will be like when there is vector a like this and there is one more vector b. So this is 15 newton, this is 10 newton, they are acting in same direction, that is theta is equal to 0. Then r maximum means this one, r max is 25. Similarly, the case 2 is when vector a is 15 like this, opposite side, and this is b 10, then vector a b resultant will be in this side minimum, that is 5 newtons. So this is geometric interpretation of the problem. So we go on to the next problem. First we understand the, so the question is, when there are two forces of equal magnitude f naught, it's acting on a body, find resultant of the two forces. So we are given is two forces F1 and F2, both are equal to F naught. So here, so in this given problem we have two vectors F1 and F2 having equal magnitude F naught. So we represent by this value F1 and this is F2, that is equal to F naught and this is also equal to F naught. So in this case we have to find what is the resultant, and it is given, it is theta. So we know as per parallelogram law, so of addition, of vector addition, r square is equal to a square plus, both a and b are vectors, cos theta. So here a and b are equal to f1 square plus f2 square plus 2 1 f2, assume. So we got here f1 is equal to f naught as well as f2 is also equal to f naught. So what happens? We substitute f naught in each one, because both are equal to same f naught. That means we have same magnitude of force. So this goes back to 2 f naught square, 2 f naught square plus cos theta. In this, these two terms are common from this terms. that is equal to, if I taking common outside of this, becomes 1 plus cos theta. So this is equal on the right hand side, left hand side is r square. So that turns out to be r is equal to root of 2 f naught root of 1 plus cos theta, right? So the answer to the problem. So here, so the resultant what we are found out is equal to root 2 f naught into root of 1 plus cos theta. So this equation still be simplified, but we can end up here. So this cos theta, if we know, we can find out the magnitude and resultant of the both forces. This video, the next question is about the resultant of two vectors a and b. It is perpendicular to a. So given our resultant r as well as resultant is perpendicular to another vector a. So here the given are a and b and resultant is r. So 2 point is the vector r is equal to the magnitude of b. And again we have to find here what is the angle between a and b. So for that, so here we have got a and b vectors, and it is diagrammatically represented as two vectors with an angle between them. So the resultant between them is passing through them. So but this is explained using our parallelogram law. So, but as per the problem, r is perpendicular to a. So this kind of representation we can't show r as perpendicular to a, so we have to use triangular law of vector addition, where we show that, see, we have to use triangular law of vector addition. So here what is given is, one is perpendicular to a, k vector, and one is b vector. So the third side of the triangular is the resultant of the both vectors, which is drawn in opposite direction. So the closing side is third side. This is according to the triangular law of vector addition. So in this problem we utilize this law to solve this problem. So here first we draw the vector a. So this for vector a, our resultant is perpendicular. So you draw a resultant perpendicular to a. So here the next vector b should be the closing side as is shown here, but the only way to draw the diagram is to coincide in this direction, whatever is showing. So let us see how it is possible. Suppose if we draw vector in this direction, the vector resultant will be in this direction, the closing side, but that is not the way the problem is given. The problem shows that r is perpendicular to vector a, but here r is making some angle, so definitely b cannot be in this direction, so it should be in this direction only. So this is a triangle, closed triangle with the third side representing the resultant. So from this triangle we can solve the problem. So here the triangle, in this triangle vector A and vector B, I am making an angle here, some theta. So using this triangular law and the triangular law of vector addition, we will find the angle between these two vectors. Okay, from the diagram, but R is equivalent to B. So we substitute the value of R instead of B. But actually there is an issue here. So there was a mistake in typographical error is there here. That is, the magnitude of R is half of magnitude of B. So it should be corrected here. R is equal to B by 2. So when you are substituting this value here, B by 2, this becomes R by B by 2B. So when this crosses out, we are left with sin theta is equal to half. So this theta is equivalent to 30 degrees. So this completes the problem. So the next is so here we are telling that we have two issues here. We are given R is perpendicular to A and R is shows that the sum of two vectors is also a unit vector. Find the magnitude of the difference. So given here is two vectors, unit vectors I and j, and given is that the sum of these two unit vectors is also a unit vector. That means I plus j is equal to k. K is unit vector here. So I plus I vector plus j vector is equal to k vector. So this is what is given. So we have to find what is the difference between them, that is I minus j. We have to find it out. From parallelogram law, we know that the resultant is equivalent to a r square plus a r square is equal to a square plus b square plus 2ab. So we use this parallelogram law of addition to solve this problem. So here a is equal to I and B is equal to J. So we substitute these values here, and here A and B are the magnitudes of I and J, that is equal to 1, as these are unit vectors, and are represented by K. K is again a unit vector. So unit vector is having magnitude always equal to 1 or unity. So when we substitute these values here, we get this equation, we get the cos theta value. So this is how it is done. So in this equation, this is 2 plus 2 plus cos theta. So 2 is common factor in this. So we bring it out 2 and 1 plus cos theta. So here again, after simplifying this, so we get cos theta is equal to minus of. So this minus of cos theta, we need to further simplify this equation, because we use this cos theta directly in the next equation for solving I minus j. So I minus j, resultant we can find with y. It's the same equation where instead of this plus we use minus. So I minus j is equal to a square plus b square minus 2ab cos theta, because so we are simplifying this equation here and substituting cos theta directly is equal to minus 1 by 2. So in this equation we will get r is equal to root 3. So this gives a solution for magnitude of the difference in unit vectors. So this completes the problem. So the next problem is the sum of two forces acting on a point is given as sum of two magnitude. That means there are two forces whose magnitude is sum is 16 newtons. If the resultant is normal to one of the smaller forces and magnitude is equal to 8, then what are those forces? So let's here we will take just given what is given is two forces like F1 and F2. So okay, their sum is equal to F1 plus F2 is equal to 16. So here we understand that it is sum of magnitude. That means it is not vector, magnitude vector. Sum of a plus b magnitude is equal to 16. If it is given without sum of the forces, then we have to consider the resultant equation. So here we are not considering resultant equation because directly the value is given here. So the next is that resultant is normal to the smaller forces. So here resultant is what I am saying is here F1 is greater than F2 we take, given that our normal resultant is normal to one of the smaller forces, that is here smaller forces is F2, that is a smaller force. So resultant is perpendicular to this normal force F2, and again given is R is equal to 8 newtons from the question. So using these three given factors, we find the what is F1 and what is F2. So we draw a diagram now. So in the previous session problem, we have found a similar problem where resultant is perpendicular to one of the forces or one of the vectors. So in this way we have drawn already in the previous problem. Similarly, so one vector is F2 and its R is perpendicular. So the only way the other vector completing is in the direction shown with the theta F1. So here from this triangle, Pythagoras theorem use. So F1 is equal to R square plus F square. Along with that, we use this F1 plus F2 is equal to 16. So F1 is equal to 16 minus F2. We directly use these two values R and F1 in this equation to solve F2. So this shows the way we solve the problem. So in this problem, so simplifying this, we got 2f2, f2 square on both sides. So this will be simplified by crossing each other. So the leftovers are like this: 256 minus 32f, 464. So from this equation, we simplify. Finally, we receive f2 is equal to 6. So after receiving f2 is equal to 6, we use this f1 plus f2 is equal to 16 and substitute the value of 6 in this equation f1 plus f2. So we simplify here and we get f1 is equal to 10. So this is how we find the individual forces f1 and f2 using this diagram law. So next we go to the next problem where it deals with resolution of vectors. So a particle simultaneously possesses velocities 2, 4 and 6, 2, 3 and 8 meters per second. As the diagram shows, we use them to find what is the resultant velocity of this all sum of velocities applied on the particle. So for doing that, we use the principle of resolution of vectors or component of vectors. That means each can be resolved into two parts, that is in one vertical direction, other horizontal direction. So the formula is then R is equal to root of v square plus h square. V is the vertical component and h is the horizontal component. So for each individual velocities, we will calculate both vertical components as well as horizontal components, and we use this equation to solve the resultant velocities. So in this diagram we see that this resultant R is resolved into two parts, that is one vertical and horizontal. So resultant is sum of all these vertical as well as sum of all the horizontal velocities. So all these vertical components add up to V and all the horizontal components add up to H. So here for this particular velocity 2, it is horizontal in direction. So there is no vertical component for this. So simply it is 2 meters per second, which is having 0 degrees with respect to horizontal. So this doesn't have any vertical component. Next is the 4 meters per second, which is making an angle of 60 degrees. And this can be resolved into parts, one along the horizontal direction, one along the vertical direction. So this angle here is 60 degrees because these two are parallel lines and this becomes the alternative angle. So this becomes horizontal direction, 4 cos cos 60, and this becomes 4 sin 60. So this 4 now resolved in two ways. One is vertical and is horizontal. Similarly, the 6 root 3 can also be resolved in the same fashion using the angle here. So here 60 plus 90 is 150, and as this makes 180 degrees, this will be 30 degrees, because as you know here the total angle is 180. So the remaining angle is 30 to complete to make it 180 degrees. So here is 30 degrees. So we use that to resolve this 6 root 3 velocity in vertical and horizontal directions. So this angle is similar to the alternative angles where these two lines, where this horizontal line and the line parallel is parallel to them. So this angle becomes alternative angle. Sorry. So this is again, we are redrawing it to understand in a better way, as that is the previous slide is so clumsy. So we are still in the same thing again in a better view. This is the horizontal component, is the vertical component. As you know, this 30 degrees is because of the 60 plus 90 plus 30, which makes it as a 180 degrees. So using 30 degrees, we resolve this 6 root 3 velocity in horizontal and vertical direction. This is sin theta because the angle is towards this cos theta side. It's sent, whenever the angle is sent to some side, that side becomes cos theta. The angle which is the side which is not having angle becomes the sin theta. Similarly, for 8 meters per second velocity, we have to find the angle here. So we have given from 6 root 3 to 8 meters per second, the angle is 150 degrees. So we have to find what is this angle in between. So this turns out to be, see, we know from here 60, 90, 30, and this is again 90. So this becomes 180 plus 270, and this in this direction this is 90 plus 30, that makes 120. So if into 120 the angle is, but the total angle is 150, so 150 minus 120 gives 30 degrees here. So 8 meters per second makes a 30 degrees with vertical here in the downward direction. So using this 30 degrees, we resolve this in two parts. One is downward vertical and is horizontal in this direction. So this is explained, showing that this 30, 90 plus 30 makes this angle. So this 8 meters per second is resolved using 30 degrees here, and this becomes 8 cos theta, because this is the angle is adjacent to this side, and it becomes 8 sin theta. So now we sum up all vertical sides to one side and all horizontal to one side. So V is equal to all verticals, that is 6 root 3 sin theta plus 4 sin 60, and this is minus 8 cos 30 because this is downward direction. Similarly, H is a horizontal one. All horizontal things are segregated. So here 2 is doesn't have any component, so 2 plus 4 cos 60 is also having the same direction as 2, and 8 sin 30 is also having same direction as 2, but 6 root 3 cos it is opposite to that, so that's why we are taking it minus. So we simplify this equation. So V here cos sin 60 is root 3 by 2 and sin 30 is off and cos 30 is root 3 by 2. So this turns out to be vertical is around root 3 by 2. Because this 2 is 5 root 3 minus 4 root 3 2. This is equal to root 3 by 2. Similarly, we solve for horizontal side. 2 plus 4 off because cos 60 is off, plus 8 sin 30 is off, 8 into 2 off, minus 6 root 3 cos 30 is root 3 by 2. So this turns out to be like minus 1. So we got H, we got V. So using the formula R is equal to root of V square plus H square. So the resultant velocity will be root of V, that is 3 root square plus 1 square, that comes out to be root of 4, that is equal to 2. So resultant velocity is 2 meters per second. So we jump to the next problem where the vector is given in component format, and we have to find what is the magnitude of the direction of the resultant vector A plus B. So here A is given as in AXI plus AYJ format, and B is also PXI plus BYJ format. So here for finding out A plus B magnitude, we know that A plus B vector will be in the form of all x components on one side plus y components on the other side. So that is AX plus BXI plus AY plus BYJ. So we are writing down in that component format for each vector. So now directly we can imply that from these two equations shown there, AX is equal to 3 and AY is equal to 4. And Bx is equal to 2 and By is equal to 3. So directly we substitute the above equation of A plus B. Sorry. So this has been represented by one more, writing A plus B as vector is equal to C vector. So that similarly that is C vector is equal to Cxi plus Cyj. So that can be written in this format again. Cx is equal to X plus Bi plus Cy is equal to that Ay plus By. It is only for simplification point of view we are representing it as C. So we directly substitute that ax plus by values from the values given. So the c vector turns out to be 5y plus 7j. So this is the a plus b vector. Its magnitude will be 5 square plus 7 square. That is also like cx square plus cy square whole root. So finally the value of c is around root 74. It is a resultant magnitude of a plus b. So for direction, we know that it is cy by cx. So it is 7 by 5. Tan theta is equal to 7 by 5. So theta will be equal to 10 inverse of 7 by 5. So this completes this problem. The next problem, we are going to find how to resolve a particular vector into two components. And the question given is, a body is moving in velocity 20 meters per second in northeast direction. So we draw the direction format, east, west, north, south. So here the velocity of a body is moving is in the direction of northeast, so in between north and east. So in order to resolve this into rectangular coordinates, that will be along vertical direction and horizontal direction. Here it is around north direction and one is around east direction. So that will be around like the side which is inclined towards theta is cos theta, and without theta it is sin theta. That is to 20 sin theta is towards north and 20 cos theta is towards east. So this is how we divide that single velocity into two directions of perpendicular to each other. It's called resolution of vectors. So we know component vector is like, suppose if velocity is v, we write it down as vxi plus vji. So here vxi is equal to 20 cos theta and vji is equal to 20 sin theta. So in order to find theta, theta is exactly making an angle of 45 degrees between north and east, because the northeast direction is half of this both, that is, a north and east have 90 degrees. Half of 90 degrees is equal to 45 degrees. So the theta here is 45 degrees. So we substitute theta equal to 45 and solve the issue. So that turns out to be the problem solution. So this is how we separate a vector into its rectangular coordinates using angular form. So the next is one more component vectors, where it's given in two ways. A is equal to 2i, b is equal to I minus j plus yk. So we have to find what is the angle between these two vectors, as well as what is the cross product between them, and the unit vector perpendicular to these two vectors. First, we find the cross product of these two vectors. You know a cross b. So here unit vector perpendicular to AB means, so when there are two vectors with an angle between them, perpendicular will be like t something shown like 90 degrees to both. So this is equivalent to almost like our cross product A cross B. That means unit vector along A cross B direction. As you see in the previous videos, the definition of A cross B, the direction of A cross B is according to thumb rule, right hand thumb rule. So the unit vector which is moving out to these two A and B vectors is perpendicular to these two vectors. So we will write in a matrix determinant format to find what is the value of the cross product. So cross product, we know that A cross B is equal to, in the format of determinant shown, I determined ijk and ax, ay along with, and underneath the case az, bx, by and bz. So using this we solve the problem. So here we are representing what is ax and what is ay, az. Similarly for bx, by and bz. These are the magnitudes of vectors in each direction, I, j, k. So ax is equal to, ay is equal to 1 and az is equal to 0. Similarly bx is equal to 1, by is equal to minus 1 and bz is equal to 5. So here I into when you use that, when using I, we have to use jk values like 1, 0, minus 1, 5 to solve. This is the format to solve the determinant. Minus j, it is not plus j, minus j into, we have to use 2 into 5, 1 minus 1 into 0. So plus k, when you are using k, it is values of I and j. We should not use the column of k. That is 2 into minus 1, minus of minus 1 into minus 1. So it's supposed to be 5 minus 0 minus j into 10 minus 1, 0, sorry, and plus k into minus 3. So this is a vector which is a cross product of A and B. So one value we got is cross product of A cross B. Next we will find out what is the angle between these two vectors, A cross B. We have to find the angle between A cross B. We use the one more equation, A cross B is equal to magnitude A magnitude B is sin theta. So sin theta is equal to magnitude of A cross B by individual magnitudes like A magnitude by B magnitude. So A cross B magnitude will find like this 5 square minus 10 square plus minus 3 whole square under root. So this gives a value of the resultant or magnitude of A cross B. It is 134, root 134. Similarly, we will find magnitudes of A and B respectively from the given values. It is 2 square plus 1 square plus 0. For B it is 1 square minus 1 square plus 5 square. So we substitute these two values in the sin theta equation, and we get that it is equal to minus 134 by plus 134 by plus 135 under root. By simplifying this irrational division, we get the what is the value of sin theta, and from that we can derive the angle. So next we will find unit vector perpendicular to A cross B. You know from the definition of unit vector is written like where the magnitude of the vector is 1. So we need to understand better way, we write it as, suppose A is a vector and it is represented in component format. It is equal to Ax into Ii to y. That means Ax is the magnitude and I is the unit vector in the direction. So if you want I here, that is A vector divided by its magnitude. So similarly we use the same thing for finding out what is the unit vector perpendicular to both A and B. So we know that we already saw that A and B, if we have two vectors, the unit vector which is perpendicular to this is the crossproduct vector A cross B according to the definition. So we have to find a unit vector in the direction of A cross B. So A cross B direction means, so using this formula, say that the vector is A cross B and the denominator has magnitude of it. So unit vector is equal to 5y. So that is a vector. See here, as problem shows, I is equal to A vector by vector of A. Similarly, from this quotient, unit vector perpendicular to A and B is this vector A cross B. So in this problem, so that ends the problems of vectors for first session. So in next session we will deal some other problems relating to resolution of vectors as well as cross product and dot product. So if you have any doubts regarding this problem solving techniques, you can keep posting comments on the channel so that I can review and I can make you further understand in a better way. So please subscribe to this channel, Fundamental Concepts at Ease, so that I keep posting many videos related to these topics on physics, chemistry as well as mathematics for the class 11 and 12 students. So please, if you like the video, please tick the bell and keep watching. Thank you.